So for you to, can you help me to differentiate the long run and short run? So using the labor in the capital, we have an output function.
In the short run, the prices are stated.
No, there's no price there.
Especially on that one.
Yes, that's one only.
So, but I think in the long run, you.
One of the factors is changing.
So I think in the short run it's changing.
Yes, one of the factors is changing in short run, right?
Yeah.
So if we are looking at an output of ERICA, right? If we are taking that the output is being produced by ERICA, in short run, ERICA will be in short run once the labor or capital is changing, one of it. Whether the capital is whether the labors are increasing or the labors are decreasing. So we'll be saying ERICA is in short run, right? So as long as one of these factor, one is changing, but in long run, both of them are changing. Labor and capitals are changing. That's why we expect in long run a growth, a high growth, right? Because both you are you can is the company is able to change both at the same time. The company is both able to change at the same time.
So in the long run, both capital and labor, they are utilized and
Yes, at the maximum point. Yes, that's why I'm saying both are changed. It can be utilized or or minimized at the same time.
So
Yes,
if we minimize it in the long run, it's not at its maximum anymore. But we are saying in the long run, both are at its maximum.
at its maximum. Yes, but what's happened in COVID shows that it's possible that you can minimize both.
So but we are still having the long run.
Both in COVID, labors were decreased and capital were also decreasing, right? But at the time, many companies was in the long run in COVID, right? But after COVID, labor started to increase, but the capital was a bit stable, sticky. That was a short term. And now now things are changing. You see? In 1 year, you can have both short run and long run at the same time within 1 year. So to means long run, it doesn't say it's a long term, no. To say short run doesn't imply to have it doesn't imply to say it's a short term. Okay. Okay, co-integration.
Hearing the sending the news by right?
So the co-integration is saying in long run there is an equilibrium, right? In long run, in long run there is an equilibrium between non-stationarity variables. Either they can be two or they can be one, three, four, five. Depends on how your model is being described. So we are assuming we have Steven income. This is Steven income and Steven consumption. But both are non-stationary, right? Both are non-stationary. But the difference of income from Steven and the consumption, the difference, it's YT. No, okay, it's consumption minus. So the difference, the gap, is stationary. So the fact that even the fact that the two series are not stationary, but the gap is stationary, we say that those two series, the income and consumptions are integrated together in long run. Who can adjust a bit? I can see there is anyone to help me to adjust a bit. Because I can see the writing a bit. Yeah, yes. That's, it means they will be moving together. Why econometricians matter? Why co-integration matter for the econometrician? Why?
Unless for study.
So there is an issue of stationarities for macro, especially macro. Macro variables, it's what you are going to use as an econometrician for the undergraduate. You're going to use macro. And then macro, they are not stationary. So we are having an issue of non-stationarity variables, which is leading to have experience regression. Is it possible that okay, if we say spurious regression, we want to mean R square is higher than the W naught. R square is higher than W naught. Okay. Who can give me an example of a spurious regression? Yes, please.
GDP.
GDP of Benin or Ghana or Nigeria with the relationship with sales from Amazon. Okay, both can be having a same direction of increase, but one can't affect the other. Or one can be stationary, the other is not stationary, right? So we'll be having a spurious progression. And then it will lead to invariant, those both tests, P statistics and F statistics. So the F statistics is looking at the individual contribution, but the F statistics is looking at the combined contribution. Yes. If I'm the one to write the denial hypothesis, for the T test, it will be beta 1 is equal to 0. But if I'm the one to write the F statistic for the denial hypothesis for the F statistics, I will be saying beta 1 equal to beta 2 equal to beta up to Kn. That's how I will be writing my H9. So you can see that the F1 is looking at the contribution alongside our parameters, but the T calculated is looking at one contribution, right? We lose the long run information. And then the solution of having co-integration is providing us a long run relationship. Those are theories. Okay, now we have changed. Ingo-Lagrange co-integration test. It's the second procedures. So we have this equation, right? We have this equation. If we are looking at yt equal to beta 0 up to error term, and then we are making a reverse. What are we testing? We are testing for the residue, right? So Ingo-Lagrange is helping us to test for our residue, whether it's stationary or not. If our residue is stationary, if our residue is stationary, we confirm that we have co-integration. So our residue, so stationarity is saying ut should be equal to 0, which means the series is not stationary. And the H1 ut is different from 0. So I'm wrong. Let me just clean. I'm writing something which is not correct. So let me just erase.
So,
Yes, please.
what's the difference between Lagrange and augmented differential?
So Lagrange is looking at, it's a test used for cointegration. So the fact that we are testing the error term, we are making Lagrange cointegration test. Yesterday we used to test our error term, right? So the error term we were testing, it's a Lagrange who discovered it, who proved the test. It's a recap of yesterday.
So it's Lagrange is for
The cointegration on,
integration, the gap.
yes, the cointegration. And then the unit root is the
one
test.
variable.
Oh, okay, let us recall. The unit root, the stationarity. Let me just help you. Let me just help you. To test, a test used for stationarity, it is DL, ADL, and PPP. Are we together? The test that is used for stationarity is Dikefura, augmented Dikefura, and field Phelan. Are we on the same page?
So
Yes. So then the test which is used for cointegration, the tests used for cointegration, the Lagrange and Johansen. Johansen. Hansen, yes, I'm coming. Yes. So the Hansen, yes. To see if the gap is yes, we use the Dikefura, but it is in the one who discovered was the Lagrange. He used other tests to confirm his cointegration. Okay, let me just go back to the previous slide. Here, we are saying if you want to test for the cointegration, we need to use the Ingo Lagrange. But Ingo Lagrange, to confirm whether the series is stationary or not, he used the stationarity for the residue especially. So that's why he checked for he created a new variable, right? He took yt negative consumption and then he got the residue, right? And then he tests for the residue by using the ADF or field column, right? So you can see he first generates a new variable and then he tests for the cointegration
using the ADF.
using the ADF. So that process, the one who discovered was Ingo Lagrange. And then the process that he was making was trying to seek for the cointegration or not. Yeah. Yes. Are we on the same page? So if I say Ingo Lagrange, it's a cointegration test, but he used within his test the ADF also. Because he was testing for the new variable that he created, right? Okay. So that's why it's a bit, so you can see that the difference in error term, and then he tests whether the error term is stationary or not. Yeah. So it's a complement. One complement the other. So without the stationarity for the unit roots, you can't confirm the cointegration. Yeah.
Outside the discussion.
These are theories.
We test that one variable.
unit root test one variable.
Last time.
Yes,
But now, the
co-integration.
yes.
The co-integration, two series,
Two series.
and then check for one series, and then test by using the ADF. Yeah.
Because you generated this one.
New variables. So and then Johansen is coming for many multiple variables. For example, we can yesterday we used to model. Our model was Y, consumption, investment, and government expenditure. So you can see now more variables has become more than two. So now we can't use Lagrange, we are going to use Johansen.
So it's like Lagrange is for two variables.
Yes, Lagrange is for two variables.
Johansen is for
Johansen it's more than two variables.
Okay.
Are we on the same page? Lagrange is for two variables, but Johansen is for multiple variables. It's a vector. It's a vector.
Johansen. You see?
He take away a summary for the co-integration. The co-integration capture a long-run relationship of my two variables, of my two behaviors from Stephen or Lina, where they're consuming respectively to their income.
Johansen is H.
Yes. The second one is it allows also to test for non-stationarity for the safetyness of our variables. It's also helping us to proceed with testing in Lagrange. Okay. And then as long as we have co-integration, we can check for the ECM. What is the ECM? A good question. ECM. It's our next chapter. E stand for error. C stand for correction. M stand for model. Can we connect those three words? Error, correction.
Correction model.
Yes, correction model is. Why? Why are we learning error correction model? Why is it essential for the error correction model? Yesterday we started a new points of demand. This is my supply and this is my demand. So I want to demand water. I'm demanding water, sorry. I'm demanding water. Okay, I'm demanding coffee, right? It's a good example. Today I'm demanding 1 cup of coffee, right? And then I made Erika to produce at 1,500, right? Because I have a demand of coffee, right? I want to be energetic one in a class. I don't want to sleep. I don't want to have some sleeps when I'm just teaching. So that's why I'm demanding a cup of coffee. But we have multiple demands. Maybe let's assume we have 200 students to drink coffee from per day from Iyerika canteen, Sokoba. What if our demand is shifting? What if our demand is shifting to D1? Maybe assume maybe Iyerika is bringing a new campuses like medicine one, and then students like to spend a lot of time studying, especially nights one. So then we have another new demand shifting to maybe 500 demanders of coffee, which will make the Erika to raise the price to maybe to 2,000. You see, the fact that the demand is increasing, automatically the price of coffee is also shifting. And then Stephen, I'm going to use those two names for this class. Sorry to use Stephen and Lena, right? Stephen is a researcher and then he wants to win the market. Oh, he's thinking that to charge 2,000 for a cup of coffee, it's too expensive for the students. And then he bring a coffee shop outside here, car. And then he's making a supply, sorry. How can he make a supply to decrease? Okay, so he's making a supply to shift here. He's making a new supply of coffee, which is making the coffee to be purchased at 1,000, right? Okay, let me just lab one line, clear one line. Okay, this one. So, yes. Why am I interested in this shift? The reason why I'm interested in this shift is because our first equilibrium was at here, right? Yes, was at was at a price of 1.5, and then it shifts to this equilibrium of a new equilibrium, right? This is the second equilibrium. Because of the higher supply, it shifts to the third equilibrium. So now my demand, we start changing our demand, and thereafter the supply also changed. So are we in long run or are we in short run? Yes, we are in long run because both both has changed. So what if one is changing?
What's wrong?
It will be the short run. If my supply is changing but the demand is fixed, so it will be in short run. How can we call it in econometrics? How can we call it in econometrics? As long if we mentioned that the both changes in two series is a long run, which implies the cointegration. If one series is changing only, it will be what we are checking for the error correction model. We are checking for the ECM. So it's short deviation for one variables. It's making us to check for the error correction. Right? To reach to the long run relationships, we need to have a short deviation where we check, okay, the supply number one was changing from S1 to S2. So that was an error correction model. So we need to look at what if maybe our series is changing. So what will happen? So recap. So our initial long run. How long does it take? How long does it take shift from 1 to 2 to 3 and then again back to 1? That's what we are looking. How long? The econometricians has predicted how long can it take from shifting from 1 to 2 to 3 and then again return to 1. So that's what we call the error correction model. We are just correcting our model. We are bringing the model to the initial point. Okay, let me just highlight with different color. How long will it take for me to shift from 1 to 2 to 3 and then come back to 1? It will be an error correction model. Okay, that is our next chapter, error correction model, ECM. If we have multiple variable, it will be VCM, vector. Are we on the same page? This ECM it's for two variable, right? But if you have maybe y equal to, oh, let me just see. Let me just change. Essentially, if we have y equal to x1, x2, x3, it will bring us a vector of our y1, y2, y3. These are my constants with x1, x2, x3. So now it's becoming a matrices. I'm having a matrices. So I will no longer call it ECM. I will be just calling it vector. Vector. I will add the vector error correction model, and then it will be VCM. VECM. So if you reason VCM and ECM, they are both the same, but the difference is that one is looking at two variables, but the other one is looking at multiple variables, especially for the x's. As long as my x is in green, so I need to use the VCM. For example, so one quick example. I want to affect my the level of inflation, right? I want to affect the level of inflation. So this is my inflation using my interest rate, the central bank interest rate. The central bank is using the central bank rates to affect the level of inflation. So if I'm in Central Bank of Brazzaville, if I'm the chief economist, I will use the central bank interest rate to affect the level of inflation, right? That would be two variable, right? To use. But you need also to check for the level of unemployment, right? The level of unemployment. Maybe for the Central Bank of Chad, we need to add also the level of unemployment, even also the money supply, right? MS. So my Y will be inflation to being affected by I as the main, but also adding unemployment and even also money supply. So now I'm no longer having two variables, right? But I'm having multiple variables. So for this case, I will not use ECM. I will not use ECM, I will use VCM because it's a vector. And for mathematicians, we are going to note it like our pi 1, pi 2. Oh, anyways. We'll be using pi 1, pi 2, pi 3, pi 4. These are models, right? Will be equal to the R for 1, R for 2, R for 3, R for 4. This is another matrix plus I, which else? which else? Plus U plus M. I think the last one was,
Investment and employment.
let me just put maybe output, the GDP, right? So now it's becoming a vector, right? It's being a vector. So maybe I'm the wrong. Okay, for those who remember mathematics for economics, they can understand. Have you had mathematics for the economy?
Yeah.
Yes. You can understand the reason why I'm just making it like this one, vertically or horizontally. Okay. So the error correction model, it's a short run dynamic. And then it is helping us to have a long run equilibrium because we are changing from 1 to 2 to 3 to 4. So we are changing from 1, these, we are changing from 1 to 2 to 3. And then again, return to 1. How long are we taking? How long does it take for us to shift from 1 and then return again to 1? Is it a year? Is it 4 months? Is it for a decade? Sometimes even journalists are asking the governor, how long will it take that the inflation is coming from 8 to 3% or to 2%? Sometimes the governor can say, okay, it can take a year. What the governor is saying is not good. She's or he is not lying, right? The economists did analysis and then they can find how long can it take to come back to the equilibrium of 3% or 2%. What techniques they're using is the error correction model. They try to shock the error time and then see how long will it takes to back to the initial point. That's what you are going to do in your dissertation also. You're going to know how long will it take for your model to return to the equilibrium. Maybe it can be years, it can be quarters, it can be days, depending on your time series. So if the variables are co-integrated, in long run, in short run, there is a small deviation from the equilibrium, right? And then the ECM is the model which is correct deviation, then return to the long run equilibrium. Okay, so with no delay, we need to make practices. But the essential key point that I need you to take in your minds, the error correction model should be between 0 and -2. Please take into your consideration the error correction should be in range of 0 and 2. Why? If your error correction is not a negative, it should be equal to 0. Other else result is not correct. And then it must be negative. It will be negative. And then it means a speed of adjustment to the equilibrium. It means the speed of adjustment to the equilibrium. So the value that you will be able to see between 0 and 2, we are going to multiply by 100 and then be able to know the percentages that you can calculate. So advantage of having the short run, it is very fast, temporary effects. Yeah. The disadvantages, but I will not ask. These are tautologies. So what I need from you is see, we can make, okay, let me see whether it's very essential for you. Oh, after doing the ECM, we'll be able to check for the normality test, Jacobella, heteroscedastic for the white test, autocorrelation. Please. I know you like that the place, but Please make sure you can follow. You need also to have a good function form by using a lamp set. And the last one is for sum. Okay, sometimes I can speak Kasum or it's Kosan. We have a long way to go, right? Okay, let us do practices. Let us do practices. We are going to check for the error correction model from yesterday one. Oh, I have just put all for my data. Okay.
So meaning that we first need to check for the correction then. So when you have check for the before checking the integration, you have to check this for the error or correction number.
Sorry, repeat again.
So it is only before checking for the integration, which is in the long run, check things for the ECM. ECM is not after. Or the ECM comes after.
No, the ECM comes after.
It's like a return.
Yes, it's a return. Because you assume all the time we are at the equilibrium. So what if the equilibrium is changing? So it is how long will it take us to come back to the equilibrium?
So, you run the ECM if and only if are correct.
Yes. Others, it's not correct. So if you don't have co-integration, you can't continue.
So it means that it is the error term that we're talking about is the U y minus. For example, if we have two values like income, the U that we're talking about that we're going to run the ECM is this U. This U2, this gap, the gap.
Yes, that's what we are going to make. Let us do it in practice.
If we have more than two variables, we use the
More than two variables?
we use the
VCM vector. It's the V is stand for the vector because you have matrix.
So I use this one for VCM. What about for two variables? What would it be? This one is for VCM. So what about for ECM?
VCM, that's what you're going to put.
Is it also in this?
No.
In matrices?
No. Not the same. It is in this way. Yes, it is in this form. Or this one. The above one being short. And then the last one is this one. You can make a reverse. Let me just help him. The ECM, the normal Eric to be this one, and then the ECM will be that we start with U is equal to YT negatives consumption. But because we are checking for the short deviation, we are going to say change in UT will be equal to the change in error term negative the change in consumption, right? We are looking at a short deviation that can happen here. How long will it take to be at the equilibrium? So, yes, please.
So things can actually improve on the station. So there is a point where
Yeah, there is a point where I should
Why one time series of
Yeah, it's very simple. Just take an example of demand and supply. So we always know that it should be at equilibrium, but in the wrong run. But the demand is not so. Did you see? Okay, the series of demand shouldn't be stationary. It shouldn't be stationary. But also the supply line is not stationary. But then in long run, we assume that the gap between themselves will be stationary. That's what we call eco-integration. Demand. It's weight. Yeah. Indeed. Demand. This is okay. This is the. It can be like this one. Non-stationary. The other one is stationary. But we assume maybe the gap between here will be stationary, right? That's why we say it will be meeting at the equilibrium, right? This is the. So what if maybe my demand is shifting here? No, my supply is shifting here. How long come back to the equilibrium? So what we call the error correction. Okay, let me just draw that, right? This one. Yes, to make it easier for you to understand the demand and supply.
It's complicated. It's difficult.
It's not difficult. So you have demand. So the normal demand is like this one, the negative one, the negative slope. The supply is an upward slope. What if we are looking at in terms of time series or non-stationary? The demand will be like in this way, in this one. So, and then the supply will be like in this way, right? So our series is not stationary, right? But we assume that the gap between here and here is stationary. So that's why we say in long run there will be equilibrium. And then now my question is coming. No, your question is coming here. What if your supply is deviating from the equilibrium? So how long? How long? So if someone is asking himself how long, it's a time. It's a time indicating. How long will it take from my new model to return to the origin? To return to the origin. So it's what we call the ECM, error correction model. We are correcting the error of deviating, right? How long will it take to return to? That's why we are going to see time.
See how things are.
Okay.
So it's like when you have a shock.
Yes, a shock. Yeah. Yes.
Causes the change in the line.
Yes,
How
exactly.
long will it take?
We did take to but okay. It's explain the theories that you are always learning in class. Okay, let us back to our simple things that we did yesterday. It's a recap, but it's also connecting to the error correction model. So we need to import. Yes, please. We need to import. Can we import our Excel file to Stata? Now it's where I'm back to. Now we need to do participants. Yes, please. Can we proceed? Okay. Yes, please. Yes, please. Tell me. Can I come to you? Oh. George. Oh, it's really.
You can just.
Is it that abasanga?
There's no connection.
The phone
I will
is
show you
the
I will share you the connection. Yes, please. Do you have it on your WhatsApp? Separate share? Yeah.
Already share this data. Now you can.
And the T bills for 12 for 90 days. You're going to paste for stationarity. For our variables, I will make paste. Yes, please.
Actually, because I want to input the data. I want to input the data in the data and work. That's what I'm actually showing.
Hey, it's not working.
I feel like I will do it at home, but but it takes longer to restore.
So you want to copy and paste.
No, just to input the data.
So do you have an Excel?
The Excel file.
Did you download it?
Yeah.
Okay, can you go to Stata directly? Go to Stata. So I'm helping your colleagues. So I'm coming to you. Oh. Now I can see.
So if you come, yeah.
Please download and then you will let me know. I will just show you the steps to import. Okay. So now we are not going to type DK folder because I have realized DK folder is bringing the DF only, not the augmented one. So come to statistics and then check for the time series. Time series.
That's fine. Go to statistics and then
Check for the time series and then select test the last one at the bottom. Last one, Ernest. Are we on the same page? Ernest, are we on the same page? And then check for the field felon. This is how we are going to make it.
what? You don't have to be unless you have someone they're going to pay. Please don't use phone unless you want to picture it or camera, right? But not phone is not around. Telephone controls it.
Field felon. And then we need to check for the interbank first and then submit. So if we submit, we have the result. Is it stationary or not?
So we put in
No, yes, you put it in interbank, the first variable.
Yeah.
Yes. And then you submit. Can we also put the T-bills? Oh, T-bills 13 for 90 days. And then we can submit. You see? You see what am I making? Very simple. You just select a variable and then you submit. You can run all the variable by submitting. If you say okay, it will be removed. Yes, please. So both series are not stationary. That is the behaviors of our macro variable. It's a behavior. It's a behavior of macro. So, yes.
I've downloaded
Are we on the same page?
it.
I'm helping you to make your assignment.
Yeah.
Yes, please.
Download it.
Import Excel. Browse where you have downloadings. Go and then select. Open. And then okay.
Okay.
No. Select the first data and now it's okay. It's in.
F1.
Browse and see. Oh, type summarize and see. Yeah, you need to encode.
I need to record this one.
You need to encode. Oh, okay. As long as my two series are not stationary, I need to generate a new variable. Don't use fonts. Fonts are not allowed. Fonts are not allowed. In my class, fonts are not allowed, but I don't want to be harsh in exam. So generate you can follow, ask question, but fonts are not allowed. We want to look at the impact of interbank against negative TB. Can we browse our U? So this is our U. We have generated our U. If you want to browse one series, you type browse. Okay, bro not brother, but bro of browse, and then you add your series. Can we plot our residual? Can we plot both our residual and the interbank and even also the T-bills 13 at the same time? Let us type scatter. Okay, two-way scatter. Two-way scatter. Okay, no. Two-way brackets line. It will be interbank TB 13 and then brackets. So now you know the issue that happened, we omit time. So we need to pop up to our scripts. Please repeat. Lina in the group. We need to follow. You need to tell your group to follow me because this is an exam. It's your dissertation that I'm making for you. Look how I can make your dissertation in within 10 minutes. Chapter 4. So now this graph is being, you can copy the graph and then paste in Word documents. It's possible.
Because what I thought again. So it's looking on.
But yeah, you see, it's not stationary. It's not stationary. You see? For those who has the units, who has the p-value which is less than 5%, use the shift alone, which will be different. But as long as you have 5%, automatically
So because
it's
it's
not
less than
less.
5%.
Yes, it should be less. And then this value is greater. But if it's 5%, we can't take a decision. We are in the margin, we are in the middle. We are in the dilemma.
This one.
But for the other one was down because it was
So the
the
one is not the
decay.
Oh, the paper it's just good.
You can add blood. Just do again the PPT, the PPT interbank.
Go to what statistics?
Time series. Mhm. Then add interbank. Add okay, display, add this one and the two last one. Select the then submit. Or submit this one. Yes, submit. Till
It's going to close
remove and then select the customer. No, submit. So we need to check.
because it's floating in the
The critical, let me see.
we have those two words. No. Why are you floating in the
Yeah. Go up No, now you can reject. No, you can say it's a station. It's not stationary.
non stationary. You're using
You see?
two variables which are
But it is becoming non-stationary as long as you don't put the constants.
because you say suppress constant
Yes, exactly. That's why it is giving you the non-constants. P, but common non-constant.
But when you did it, did you suppress the constant?
No, for me, it's because of this version. That's why we want to have the same result. Your version is very powerful to make a model to be stationary, yet it's not stationary.
Contribution.
Your version is making a mistake. It's making a mistake to change a series to be stationary. It's stationary. And by graphics, how can we say that the interbank is stationary when once you have the first mean here, have the second mean here, and have the third mean here? Means are different. No one can confirm that this is stationary. It's a drunk. It's a land of drunk. By graphic, first plots. Plots. Okay, let us plot. Please line interbank. Let us plot a line interbank. Time. Okay, this one.
Not two ways.
Not two way. You just want to plot the only the interbank rates. You see, it's a random walk. This is a drunkard.
Why do we pick two? Why do we pick
From
two
Arsenal.
ways?
For those who have watched Arsenal at the bar, to home. The guy was a bit moving the Sinzoda in one. I know fans from Arsenal, they have celebrated. So this is the work of a drunker from the match of Arsenal. So yesterday, yes, you can see something. It's a station. Okay, it's not station. Biographically, it's not station. That's why, because of your version, it's very. I don't know. Is it having a license?
If it is
19, because
the gap is between there. This guy will continue to move in that area.
that's why we need to check by constant, non-constant, not constant by trend, and see. Now, for the class to be quick as possible, I'm just using one test. But in your research, we need to do by trend, non-trend, no intercept, by intercept, and see. So that's why I want to just grab 15. But 15 is free, but it's not compatible in Mac. That is the issue. But your version is very good. But you should have not used the MP. You should use the EC, the standard version.
So now
using the MP. MP is the heavy version. For more information, for more complex data. You should, okay, but you can remain with this. If it's end, you'll be using the EC, the standard version. But you'll be charging. That is the issue. But you can maintain. You see, this is IC, Stata IC, or Stata standard. This is standard one. But no, don't worry. What we intend is what you remain in your head, right? That's what I want. Please. Can we check for the error term, the stationarity for the error term, our gap,
so we get what?
statistic, time series. We have already generated. You have already generated the gap.
Function of time.
Statistics. And then we come to test, and then felon. We select the difference, the gap. Can we submit? Is it stationary? Stationary. We can also add a trend and check. Please check the trend. Please add the trend. We are going to check for the
Well, we have to generate report, right?
yes, you need to uncheck. You need to check for the including the trend and then submit.
Mhm.
Still, we still have 1%, and then it is less than 5%. We still have the result of 1%, which is confirming the gap is stationary. Can we also add? Can we remove the constant and then submit? Still, our T calculated is higher than T critical. Take 21 compared to 7 in absolute, it's higher than the T critical. We still confirm that our error term or residuals are stationary. So I'm just changing. How can we? So, okay, this was to remove the trend. Let me help you to understand. For Eric and colleagues,
It's like when the trend is becomes non-stationary.
for you it's become non-stationary. How?
It's 0.01.
No.
Hey, 0.
Yes. So
0.01 is
can we take 0.001 times 100? Please give me the answer. It's 1%. 1%. 1% is less than 5%, which means we accept our H1. Can we interpret here the T calculated and T critical? Who can interpret? Who can compare the T calculated and via T critical?
but the T statistic is greater than the T using the absolute value.
Yes, 21 is greater than it's greater than 7. So 21 is coming from here, right? And then the 7 is coming from here. So as long as my T calculated is greater than T critical, what is the decision? What is the decision? If my T calculated is greater than T critical, I reject this neither hypothesis and confirm that my series is stationary. So when my residuals are stationary, it means though my interbank was moving in this way and my TBs was moving in that way, the gap between was stationary. The UT was stable, right? Alongside the time. Don't buy any. Your rates by this. That's why it's very.
You will buy on yourself. This guy, he used 300 the best starter. I know.
No, don't buy this.
I told
I
you.
made you with this one.
I will
show you how you can get it.
You will buy. You will buy. If you have listened.
Don't buy. Yes, please. Okay.
I saw him. It's so not economical.
Why not on the
The lecturer doesn't want to make you feel bad.
It's the last version.
So it's the one that you buy.
Using the 15 and I'm using the 19.
It's the one that you buy.
See the energy. Can you
It's not
just
the one who bought it.
Most larger is so your result. Why don't you?
Connect to your WhatsApp.
Non-stationary.
Somewhere where it's not stationary, if it's stationary,
You cannot even use it.
can I use your adapter?
My phone is.
Yeah, but you're losing this play.
What do you want to buy? So what is that?
Yeah, I want to use mine. Oh,
some of the times one of the I'll come and check this.
oh, sorry. What is that? What? Eh? For what?
Charging this one. Pongi, I'm sure that it's been fun.
There too. Yes, please. Hey, you want to explain to her? No worries. Please take just let me see from my this time this thing is the same thing. Can you generate? Just minimize. Then go to state type or type someone. See, the other one is solution. So you need to change the size. Eight. So they want. In code var1 comma generates bracket time. Declare. Series you're going to type TS set time. This
Generated random walk. What would you say?
that is the next step.
That's where we are.
Can you also test the penalty? What to pay? Units means so are we on the same page?
What is on this board? I think you got it. What's it, right?
No worries, no worries.
The best one.
Because of the nature of our time. Our time was not matter a lot, but now we can what it needs. And this like beautiful.
Everybody is.
Or just type PP. PP. Yes, PP. PP interbank. PP. PPT. TB13.
Yeah. The statistics, you should
Yes.
do the last. Yes, you could do really good. Yeah, well, the other way. Excuse me. When they feel like you say build up the senator is build up the response. You
What do you want to do? You want the graphic?
Yes.
better because if you was you try to do another thing. That's I know how to like random ones. So grab on this
So you didn't do the same for the TV.
grab downstairs.
Yeah.
Oh damn.
Okay, let me grab it.
Let's move on to that.
I can see I'm not going to Be full. Be full. And then you just put a variable.
Voila.
How do you do it?
Which one? Name the date.
Come on, you. That's the kind of selecting the
Sure. Okay, okay.
No, but if you
Let's start to start. Just the commercial. Let's say commercial. What about it?
where did you know that? The red one? Huh? I love that. You have the layer? A layer? You did? You didn't have that. I see that.
Class, let us do the last one, the last test. So the ECM. ECM. So ECM stand for the error correction model. So you want to look at the small changes. As long as we have co-integration, we can follow for the second method. So ECM, we are going to type follow, please. Our command will be the change in error term, right? Change in error terms
You okay? It's everything.
will be equal to a constant change in interbank. So what is affecting the TB? Is the TB affecting the error term? No. Is the TB which is our y, which is our x for this case?
Why is interbank?
Interbank? Interbank affecting the T-bills? No. The central bank should affect the commercial one. The TB, okay. Yes. The TB from central bank should affect the commercial interbank rate. It's not the reverse.
Interbank.
So the treasury bills rate should influence the interbank rate.
I thought it's the commercial bank was give.
Other way around, it's also possible, right? It's also possible. The reverse is also possible. So here I'll be just write TB, right? Change in TB, and then change in error term, but with the rag -1. Because I already have my original change in error term.
So that's
So the error correction model will be, let me just regress.
So we cannot see the interbanks. The inter.
No, you can't see it.
We do for both or
No, we do one because our regression is this one. Regress interbank TB 13. This is our regression, right? But we need to look at X only. We need to look at our X only. You need to look at our X only. We need to look at our X only. So this is, we need to look at our only X. So that here was interbank. So we need to look at our X only. Our X here is interbank. So sorry for being mistaken. So we are going to look at our change in interbank, but respect to the D. the T bills, change in T bills, but the error term will be negatives. Right? That's what you're going to do. Our error correction model will be change in TB constant plus change in interbank plus our residual negative, it changes, right? That would be our error correction model. So our error term should be also in Chile. So in theta, we are going to type regress d dtb space d interbank with dots space with d u oh, is it u? Let me see. Yeah, there is no change. There is no changes here, right? It's a lag. It's a lag view. This is how our code will be instead. Then we are going to see whether our lag is negative. If our lag is negative, it will be very perfect for us. How do we?
We already have a UT. Where do we
UT?
account for the lag? How are we going to do it instead?
So lag, so you type L on L, and then dots the variables. So it's regress, please, to be together. D dots, add your interbank. Is it interbank?
Yes.
It's T-bills. Yes, please.
In my
In my special.
Back there. In the corner.
You need to check for the guy there who is sitting at the bottom. Yes. Yeah, the brown one. Oh, so this is my Y. So, but the difference. And then my X also in difference. And then L lag dots U. That's what you are supposed to write. Are we on the same page? The change in T-bills, the change in interbank, the lag in our residue, our gap. So the D is stand for the difference.
So the L stands for
Yes, the L stand for the lag. But I don't know whether it's worked. Okay, let me just make it.
what?
If not working, okay, it's reworked. Wow. You can see the result.
We all got different things.
It's a big issue.
So,
I don't have a negative.
so,
Yes, please.
but we all have different numbers.
You have different numbers?
Yeah.
Why? But yes, it's possible to have different numbers. But I still have an issue.
The D,
I still have an issue. Let me just make a reverse before showing you the issue that I'm meeting.
There's no negative.
Yes, now the issue is solved. Okay, let me just show you the issue that I had from the first equation. Was that my lag was positive. Who remember the theories behind the lag? The negative, yeah, the coefficients of the error term will be between 0 negative 2. And then here my coefficients was positive. So which means that my error term was not going to be a speed of adjustment. So that's why I made a reverse, and then I start with the interbank, the change in interbank respect to the change in T-bills. And it's give me a lag for the residue which is negative. So now I'm safe. Otherwise, I was about to lose my error correction model. Okay, let me just repeat once more. Let me just repeat once more. Oh, I haven't kept anything for you for the class.
So does it mean that the Y is the interbank? Answer.
Does it mean
That the Y is the interbank?
yeah, now for this case, let me just copy and help you together with this. The first model Y was our Y was
ATB.
TB, and then X was interbank. What we did was to add D. A D stand for the difference. The D stand for the difference.
Change.
And yes, the change. The D here stand for the difference. And then add a lag of U dot U. So what we realized it was that the lag of U was positive. And then for the error correction model is stating that we need to have the lag which is between 0 and negative 2. Our lag should be negative, but this lag was essentially positive. The conclusion was to be wrong because we had a lag which is positive. So we alternate our model to be y, x. Our y changed to be interbank for the second model, and our x changed to be T-bills. And then we proceed with L, U. So see what happened to our lag? Our lag now became negative. Negative how much? 0.13 negative. Now we can start to interpret the speed of the gas. So can we make this valued in terms of percent?
15.2%.
It will be 13%.
So
Remember, observation is in terms of months. The negative, we just put in absolute. We can't say negative 13, no. We just put in absolute, but we need it to be there, right? So remember, our information was in terms of monthly basis. So can we take 100% divided by 13? Who can tell me the number? 100 divided by 13. 100, take your calculator and then compute 100 divided by 1. What is the answer?
7.69.
Oh,
7.69. 7.699. This is a good number for you to remember every time. 6.7 is representing months. It will take for our model to recover from a shock. Right? Are we together? It is 77.6 months as a speed of adjustment to recover from a shock. So any shocks coming from the central bank, we make our interbank to react in 7 months. If our chief economist, if the chief economist of Rwanda is changing the T bills, okay. Our Y was okay. So yes, if the chief economist of Rwanda is changing the T bills, maybe from 5 to 7%, so the interbank will react in 7 months. The interbank will react in 7 months. What if our data set was in year, not in months? It will take 7 years to adapt to the changes that are happening in my X. What if my data set is changing into year? It will require me to the speed of adjustment of 7 years. So that X is affecting my Y. Because we are looking at how long does it take my X is affecting my Y? How long? In terms of error correction model, it's 7.6. How did we receive 7? How did we get 7? Was to take 100 divided by the 13 of our error correction model. And then we got 7.6. So this is how, that's why the governor can say, okay, for our chief economist to impact the level of inflation on the market, it requires 12 months.
So 100 represents what?
Yes?
What does 100?
100, it's because we assume the shock is 100%, and then we want to know how many durations are we taking to recover the shock of 100%, or to complete the shocks. It will take us 7 months. If there is a shock from T-bills, of 100%, it will take us 7 months to be recovered in our interbank rates. So now, the remaining thing that you can do is the last one, and then your dissertation will be ending. We are going to type Kosam, sorry, not Kazum. Okay, you can regress your interbank against TB 13. Oh, it's not around.
Because insert.
Yes, inter regress. Yes, inter and TB, and then bring again your normal regression, right? You can interpret the coefficients and then type. I don't remember the cosum. Is it cosum? Cosum? Oh.
Itself?
I want to check how the cosine is going to be used. So we need to take our cosine and then add interbank and TB 13.
Is sick.
4 years past.
So you need to install. You need to install. I think you have connection, right? So you're going to install this command. Since install call sum6. Since s double s install call sum6. Okay, for those who don't have connection, no worries. But you'll be interested to install. I know. You'll be interested to install. Oh, you can see.
Oh, that we should press enter.
This is my maximum. Okay, let me just number 20. Number 28. Yes, please. Since double AC install calls some 6. This one. Yes, please. Yes, please. This one, yes. We install some 6. Yes, sir.
Naming activities.
Yeah, so I started talking.
This is the code. Please class, please class, write this code and then just hit as long as you have internet. Now you wait. Already. Are we on the same page? Have you installed? Okay, for those who have installed, please type custom 6 and then add your interbank rates, add your TB 13, and then comma. Just again put your lower and upper bands like this one. So please write that code if you have already installed. If you already installed, please type this command.
Yes.
I'll, let me just show you the results and see. No, I will bring it again so you can see. So the command will give me this plot. The command will give me these plots. The command again.
Yes.
So the command again is this one. The command again is this one. What collector? The command again is this one. Don't stop. I'm just giving you how you can end your dissertation in one hour. But you don't. I see you in August. Yeah. After 7 months. After the speed of adjustment. So when you are going to be first. From this? Hey, you want one to be a supervisor. I want the English to hash it. You don't do it. You won't do it. Okay, so what I want here is that you will be able to convince him. Sorry. You'll be able to convince him. So as long as you're doing the
My
same,
comment is not running.
it's gonna complete the bullshit. So you say, oh wow, Michael, you did it. Now on board the lines in I don't need to challenge you, right?
Yeah.
Yes, please.
My comment is not running.
Oh, it's an just listen this one its data is very sensitive. Use the enter. The one which is there. Is no, don't type.
Oh,
What are sensitive? Remember.
so I should just.
That you can estimate that when the guys will leave the class. So we are going to leave attendance at 9. Yes. I don't want them to go. Yeah, just follow. I will just give you 1 hour to revise within the class. Then I will leave you. Now, can you do the same as your colleague is making? Yes, please. Come again. Oh, wow. Good. Yes, oh, yes. You put me to 25. 2-1, yes. Yes, my colleague. My colleague. Okay, confidence. Next one is your colleague. It's let's make help your information. I will interpret that for. No. The tsunami. Can you just make your okay, that's good. I want you to have it nothing.
How is it? Have you solved your problems? Or do three.
Please connect 80% we have the graph, right? Yeah. Despite for those who don't have internet. So the cost sum is who can detect the time. The starting time is this one, and the ending time is this one. But the issue is this one. The issue is this one. Let us come back to the theory. Yes, please.
So, we need to rest the questions.
Okay, I will let you make a comment. But the issue is this one. The system will detect that we have made
So, because if we have to explain
Okay, let us follow this one and then we are ending. So the lamp states. Let us explain this one and then we are going to end the class. So the lamp says it's connected to the results that you have. It is saying a variable can be omitted or being added or misfunctioning. The lamp set test is testing whether the model, your model, is omitting or is adding, or is giving a long function form. Our result, essentially our result, this is our result is this one. We need to cut and then explain. Do you see the upper bound and lower bound?
Accessibility shortcuts.
That's good. This is my lower band. Lower band. That one is an upper band. And the red one is my model from since the inception. Since the inception up to the ending. So my model was between the band. But reaching to this year, it goes out. It goes out. It goes out the band, and it's a return again within the band, and then hits the upper band and goes within the band. If our model goes out the band, our model is not well specified. It's an indicator that our model is not well specified. Though we had a co-integration, though we had an error correction model, but our model is not so well specified. We need to change, right? Tomorrow we are going to see how we can change, and then this red color can come within the band. Yeah, are we on the same page?
Okay.
And
So, you said that the cosine checks for
check for whether the model is well specified. Check whether our model is well specified. So this is an example of a paper that I was trying to do for the central bank. It was the determinant of export diversification in Rwanda, right? And then I used the ARDL empirical evidence and see the error correction model. The coefficient was 1.9, and it was a negative one. But what I wanted to help you to see, ECA result. Let me see whether I have an ECA result. Yes, you can see the ECA result. The cosine was between the band. So that's what your supervisor will be wanting. We want that your model, the line in the middle, will be within the two bands. Let me just again highlight, copy, and paste to. So here, and looking at this result, the ECA here. So the model is starting from 2004, ending to 2024, right?
Yeah.
But the line is keeping within the upper band and the lower band. So that's what your lecturer or your supervisor wants to be the result. So as long as maybe the model is deviating, you need to check how you can correct this issue to be within the band. Big, big work for you. You can spend a whole month fighting to see whether you can just fit the line within the band.
But they didn't take the whole month of video.
Yes, everything can be correct, but your model parameters can just continue being out of the band.
So,
Till you get to
is this not depending on the data that you have?
Yes, it can depend on the data, can depend on how you can apply your logarithm, or it can also depend on how many variables have you used, whether you have relevant or irrelevant one. Thank you. I will be having an attendance, but don't shout, don't disturb.
no one will stop.
And then after ending the attendance, you can go home.
All right.
But don't disturb. Don't disturb.
Just sit and ponder, digest all this.
Why you want?
Problem, boy. Why does he have to go in the glass?
So,
I never know something.
Are you coming tomorrow?
It's another right.
Wow.
actually,
Are you the wise lady?
I am.
I found the product. You know how it's two ways. Yeah, actually, in starting, this is
Alright.
so I have to change it from my Excel. Maybe a lot of things.
yes,
No way. It's good.
no, it's okay.
This one, the theta result. This one,
Yes. Just you can just draw. You can just draw.
and it's also take a picture of this is all the steps.
Yeah, it's I'm doing that from beginning. Let me start for you also from beginning, so it can be clear. خلاص ما في مشكلة لأنه ده نفسه مجال المباراة وعمل شنو أنا عشان أعمل براكتس بعدين خلاص كيف I didn't answer that. أنت ما عندك؟ Steven? Yeah. ده التصور من بداية؟ من امبارح صور يعني.
I know all this stuff. After that, I'm minding that setup for internet. Thank you.